Mr. Schwanecamp back again. We are working on systems of functions today. Here's the good news. This is no different, not a single bit different than what we did in 9.3. So if you were good at graphing functions, no different. If you weren't great at graphing functions, then you got to work on it a little bit here. So if you weren't great at section 9.3, I would go back, look at Khan Academy, look at Quizzes, and try to figure that out. Desmos is going to be a friend today. I want you to do it without Desmos, but when in doubt, figure yourself out here a little bit and help your process. So the main idea today is we are graphing two of the functions that we did in the last section at the same time. All we are going to do is with those sections is figure out where two things cross. If you figure out where those two things cross, we win. So that's what we're going to do here. Let's see how that works. On number one, we are graphing the square root of x plus 8 plus 3. Let's graph it. So if I'm graphing the square root of x plus 8, the plus 8 is going to take me to the left 8. The plus 3 is going to take me up. So left 8, 1, 2, 3, up 3. Excuse me. It is a square root graph, so my pattern is 1, 3, 5. So I'm up 1 over 1, up 1 over 3, up 1 over 1, 2, 3, 4, 5. I could keep going if I wanted to, but that's going to be my basic shape. Negative 1/2 x plus 3. So this is a line. The plus 3 is the y-intercept, so I'm going to go up here to 3. The slope is negative 1/2, so I'm down 1 over 2, down 1 over 2, up 1 over 2, up 1 over 2. For today's purposes, they better intersect at a fairly good point, on a line there, and it does. It is intersecting at the point negative 4, 5. That is the answer to this question. That's all we're doing. We're graphing two at the same time, figuring out where they cross. Let's just show you that I didn't make that up. Square root of x plus 8. We're going to throw a plus 3 on the end because that's what that shape looked like. And then we graphed negative 1/2 x. Just kidding. Negative 1/2 x plus 3. There are the two shapes. Where did they intersect? Right there at negative 4, 5. Exactly what we just did, but we did it by hand. Let's do another. X plus 3 squared. So that is a parabola. This plus 3 is taking me to the left 3. The parabola is 1, up 1 over 1, up 3, 1, 2, 3, over 1, up 5, 1, 2, 3, 4, 5, over 1, 1, 3, 5, parabola. 2, 3, over 1, 1, 2, 5, over 1. I do want to be pretty precise on this graph because I am trying to figure out where they intersect. So the more precise, the better. I'm graphing x plus 5, so that is a line. I'm going to start up here at 5 because that's the y-intercept. My slope is 1, so I'm up 1 over 1, up 1 over 1, up 1 over 1, down 1 over, boom, intersected it right there at negative 1, 4. But that's not all. Down 1 over 1, down 1 over 1, down 1. Ooh, intersected it again, this time at negative 4, positive 1. Both places are intersection points. What that means is I could plug in this ordered pair into both of these equations and they would be equal, and I could plug in this ordered pair and they would be equal. That's what we're trying to do. So my answer on the first one, I didn't know I had an answer line, was negative 4, 5. On this one, my answer was negative 4, 1 and negative 1, 4. Those are my answers for those graphs. We could solve through substitution. So I would rather graph it, but we could do substitution as well. Let's graph it first, and then I'll show you the algebraic way. So y equals x squared. That's a parabola. Up 1 over 1, 1, 2, 3. 1, 2, 3, 4, 5. Boom. And boom. Kind of. There we go. Man, that was rough. And then x plus 6. That's a line. I'm going to go to 6. My slope is 1. Up 1 over 1. Up 1 over 1. Boom. Got 1. Down. Boom. Got another 1. There are two different intersection points. It looks like my answers are at 3, 9. That's what this ordered pair is. And this one looks like it's at negative 2, 4. I was a little rough on that graph, but that's what I think it is. And I could do it by graphing, but I could also do it through substitution. Since this graph right here since this equation is already y equals, I'm going to take this x squared and I'm going to substitute it in for the y in the other equation. So I'm going to make it this. X squared equals x plus 6. And we could have done this on the problems up above, and then we could solve this guy. So I'm going to subtract. This is a quadratic. I've got an x squared, an x, and a number. I'm going to subtract everything over and make this problem equal to 0. Remember, to solve quadratics, you need to be equal to 0. To solve this thing, I need two numbers that multiply together to get me 6. How about like 3 and 2? And they need to add to get -1, so -3 and +2. Those two numbers add to get -x and multiply to get -6. So what are my answers? My answer is x is equal to -2 and x is equal to +3. Those are my two x values. How could I find the y value? Well, I would plug in those numbers in the beginning. What is -2 squared? That would be 4. What is 3 squared? That would be 9. Hey, guess what? That's exactly what we found by graphing it as well. So you could do them through substitution as well. Don't think you're only going to graph them, but most of the time graphing is going to be the easiest way. All right, especially one like this on the backside. I don't want to try to do this through substitution. I want to just graph. +4 is taking me up 4. It is a cube root graph, so it's going to look like that. My pattern is 1, 7. Up 1 over 1. Up 1 over 1, 2, 3, 4, 5, 6, 7. Down 1 over 1. Down 1 over 7. I moved that. I missed that dot. It should be out here. I only counted to. There we go. Then I'm graphing x plus 8 cubed. So this plus 8 is going to take me left 8 because it's inside the grouping symbol and it's plus. And the plus 2 is taking me up 2. So left 8, up 2. Good news, I'm just using that dot right there. It's 1, 7, 1, 7. Where did this graph intersect? Right there at the point -8, 2. That is the answer to this system. One more, x squared plus 1. If I want to graph -x squared plus 1, the plus 1 is going to take me up 1. It is a parabola and it's negative, so I'm going to go down 1 over 1, down 1 over 1, down 3 over 1, down 3 over 1, down 1, 2, 3, 4, 5, 5 over 1, parabola, parabola, good. Now we need to graph this guy, x squared minus 7. That minus 7 is going to take me down 7. And it's a parabola, so I'm going to go up 1 over 1, up 3 over 1, up 3 over 1. Good news. I have found out where they intersect. Those spots right there, they're going to intersect at -2. What is that? -2, -3, and 2, -3. Those are the two answers. Again, we could have done a substitution here and made x squared minus 7 equal to -x squared plus 1 and just kind of substitute. Add this x squared over and get 2x squared. Subtract that 7 and get 8. X squared is 4, so x would be equal to plus or minus 2. Hey, guess what? That's where my answers were going to be. So we could do substitution. We could graph them. Either way, we're going to solve our system, and it's all about where do those graphs cross. Hope that makes sense to you.